Hello teacher, this is my homework 7 video. I want to show the homework. Homework is to implement the deep first search algorithm to solve the topological sorting problem. Deep first search algorithm can help to solve the topological sorting problems. First of all, I want to show the some example because to implement the topological problem, I think we can do the two way. First, topol with the code, with my code. The other is the imaginal. We can do with imaginal. I didn't understand which way do you want to. Do you want to? That's why I did the two way. One way is the code with code. The other way is the imaginal with the some image, subtract the image. Yes. First of all, we have some undirected graphs, and we solve the topological sorting. We have the I think two graphs, undirected and directed graph. In the undirected graph, we have no array. The are numbers. Yes, we path, but not the direction. There is no direction. The are numbers. For example, the one going to 3, but maybe 3 going to 1. We don't know. But that's why we call the undirected graph. But in the directed graph, yes, we can clearly see the 1 to 3, 3 to 2. Also, for example, 3 is not going to 1, but 3 going to 4, 4 going to 3. And then we also can show like this, like this way. First of all, yes, we can show the 1 to 3, but in the answer we can't see the 3 to 1 because there is no path. Okay, I go back to this is the matrix using for example, in showing the like this, the 1 cannot go to 1 clearly, and then 1 cannot go into 2 because there is no path, there's no way. But we can see clearly 1 is going to 3. That's why we using the 1. We showing the binary numbers. 0 means no, 1 means yes, it's going to. It can be going. Okay. How can I explain another thing? I think no. Our time complexity is the O(n plus m). Okay, that's enough. I think I can show my code way and explain my code step by step. Okay, that's enough. This is my code. I want to copy and paste my IDE. Oops. This algorithm is an implementation of the topological sorting problem using the deep first search approach. The topological sorting problem is a problem of arranging the vertices of the directed graph in linear order such that for every directed edge vertex U comes before V in the linear order. The algorithm starts by creating a stack and a set to keep track of the visited nodes. It then performs a DFC on each node is in the graph, starting with the nodes that haven't been visited yet. As it visits each node, it marks it as visited and recursively performs DFC on each of its neighbors. Once all the neighbors of the node have been visited, the algorithm pushes the current node into the stack. This process continues until all nodes in the graph have been visited. I can show you in your slides, because in this slide really good example to explaining the these sentences. Let me show you. There is an example, good example in this slide, like this. Yes, we start with this node, and then we going to do this node, and then go back to this node. Each node must be visited. If, for example, we going to do this node, if you see my, I hope you see my mouse. If you go to this node, there is no way to left, right, up, down. That's why we have to go back to the start node, because there is no way, there is no path to other nodes. That's why we're going to go back to the start, and then we go the other nodes. Okay. Oh. Yes. Okay. These are the green ones, the explore nodes before. I want to go back my code and explain step by step again. After all deep first search travels are completed, the stack contains the nodes in topological order. The algorithm then returns the stack as the final output. This algorithm is useful for solving problems that require an execution of tasks in a specific order, and where the tasks have dependencies on each other. For example, it can be used to schedule tasks in a build system, or determine a linear ordering of courses to take, or to order the completion of the software project, like a to-do list. Yes, like a to-do list. This is my code. Create a stack to hold the sorted nodes for this code, and then create a step for the track of the visited nodes, because we have to visit all nodes, and return the sorted stack. Mark the current node as visited. We have to mark to visited code, and then perform the DFC on each adjacent node. In the our courses, we did this adjacent like a matrix. As before previous slide, I showed how can we did this matrix, the which condition, like I said that the binary numbers we use, 0 means the not visited, işte, in the undirected graph 0 means the we can't go this path. 1 means the yes, we can go this path. There is the way. Okay. At the final step, push the current node onto the stack. Yes, I run this code and sorry, but the uh, our output is the 0, 1, 2, 3, the topological sort. And this is my end of the video. I hope it's I explained it clearly. Thank you for listening to me.